So what do you think we're doing today? So we'll be introducing the concepts of roots one more time because I don't think we did it very well in the last lesson. We talked about roots but didn't really see what they meant visually and then how we calculate them. And we'll discuss the square root property and how it relates to a quadratic. And then we're going to finally find the roots of these two types of equations. We've got y equals ax squared plus k and y equals ax minus h squared plus k. And this is our first foray into factoring. And how we know we understand? We could literally understand and explain why we have two possible roots sometimes when we have a parabola, and be able to find the solution to any version of a quadratic that has those two forms, either this or this. And we can use that to solve for any kind of parabola and with respect to things that are in vertex form very easily. Sometimes it works, sometimes it doesn't. We'll talk about that later. We'll tie it all together later. But right now, we're figuring out when we have two roots. We studied the original parabola, y is equal to ax squared plus bx plus c. And we just finished studying the vertex form and the intercept form. But today we're going to focus on these two forms of the vertex form. Y is equal to ax squared plus k, and y is equal to ax minus h squared plus k, and any variants that happen inside here as well. So let's begin. The new concept that I'm going to introduce you to is called the square root property. So this concept, the square root property, is this. In some cases, it's just faster to take the square root of both sides of an equation. In these cases, we apply the concept that the following is true. If I know that x squared equals n squared, then normally you'd just say x is equal to n. But really, because of all the studies that we've done so far with quadratics, if you think about it, if I had y is equal to x squared, we already know that our graph looks something like this. Now, let's say that I had a graph that looked something like this. It opened down, but it crossed the x-axis at 2 points. So that means that there's a point equidistant here and here from the axis of symmetry. And if the axis of symmetry just happens to be the y-axis, then if this was -3, this intercept was -3, and then this intercept had to be +3. So that's basically what we're looking at when we're talking about the square root property as it pertains to the parabola. And for that reason, we have x is no longer really equal to n. So if I have x squared, I should be able to find not n, but plus or minus n. You have a plus version of it and a negative version of it when we take the square root of both sides. So I know that you may have used something like this when you used Pythagoras theorem as the very last step to find either the A, B, or C of a triangle. But this time, because we have to consider the shape of our parabola that we have right here, we need to consider that plus or minus. So from now on, you should be able to follow along with the notes that I have online. Now, here is the reason why we're doing this. The reason why we would use this is if we had an equation like this: y is equal to x squared minus 25. If I ever asked you to find the roots, or otherwise known as the x-intercepts, this is when you would use that. Or you had a problem that looks like this: y is equal to 2x minus 5 squared, and then minus 50. So you could use one where you have your parabola that looks like this, or looks like this. Now, the real reason we're going to do this is because we just need to practice that property that we talked about before. Remember, it was called the square root property, where if I knew x squared is equal to n squared, that means x is equal to plus or minus n. So now, here's the next question. How do we solve? Well, this is how it's done. 1, you isolate the x squared term. So i.e., you actually solve for what x squared. You solve for x squared. You get x squared by itself. 2, once you've done that, you have to square root both sides. Okay, and then 3, you just solve for x. Okay, so now let's go on to some practice questions to set us up for that, okay? So go to the section on your page that talks about solving for x, and we'll do some basic problems. All right, so let's say I have x squared is equal to 25. I take the square root of both sides. When I take the square root of x squared, I get x. Now, from now on, anytime you take the square root of some number, you're always going to write plus or minus the square root of that number. So now, plus or minus the square root of 25. Go on your calculator, punch in square root 25, and you get, bring down the plus or minus, 5. So x is plus or minus 5, which means that the solution can be broken down into 2 parts. So x is equal to 5, which is the plus part, or x is equal to minus 5. So literally we have 2 solutions. So our solutions are x equals 5 and x is negative 5. So now pause the video and do the second problem on your own, and then I'll show you my solution. Okay, so x is equal to plus or minus 36, which means x is equal to plus or minus 6, which means our problem splits into 2 parts. X is equal to 6, or x is equal to minus 6. And I guess we're done. All right, so now suppose I had an equation like this: x minus 2 squared is equal to 25. So what you're going to do, we're going to do exactly what we did before, except this time we're going to keep this part left alone on the left side. So we're going to get rid of that square by transferring the square to a square root on the left side. So we get plus or minus the square root of 25. So we have x minus 2 is equal to that. Now, let's simplify the right side. So we get plus or minus 5 is x minus 2. So if you want, you could go and take this problem right away and say, well, this means x minus 2 is equal to 5, or x minus 2 is equal to negative 5. And then you know how to solve for x. So in this case, we're going to take the 2 and we're going to move it over here. So you're going to get 5 plus 2. So x is equal to 7. And then we take a look at this or part and do the second half. So now we have x equals negative 5, and we're going to take the negative 2 over to the other side. So we have negative 5 plus 2. So that means we have x equals negative 3. So our answer is x is equal to negative 7, or x is equal to 3 for our final answer. So now, imagine I have a problem like this. Same problem again, but I have a 2 in front of the bracket, and I have x minus 2 squared is equal to, say, 200. So here we go again, same problem. And now we have 2. X minus 2 squared is equal to 200. So when we do this problem, we're literally going to have to we're going to have to take a moment, take stock, and we're going to get this part here all by itself, the x minus 2. So to do that, we have to get rid of the value that's in front of the quantity x minus 2 squared. So we divide both sides by 2. So now you're left with x minus 2 squared is equal to, well, 200 divided by 2 is 100. So you just punch that out. If you get a nice number, you're good to go. If you don't, you could leave it as a fraction. It doesn't matter to me, as long as you get the final answer with the radical or not. So now we have to get rid of the squared sign. So to get rid of the squared sign, we end up with x minus 2 is equal to plus or minus the square root of 100. So that's plus or minus 10. So x minus 2 is equal to plus or minus 10. I'm going to show you another way of doing this, getting x by itself. I like doing this. Take my minus 2 and I'm going to move it over here. So I know that's going to be a plus 2 in the end. So that means I've got x is equal to 2 plus or minus 10. And so now this problem breaks into 2 parts, just like before. And you'll write x is equal to 2 plus 10, or which simplifies to x is equal to 12, or x is equal to 2 minus 10, which means x is equal to negative 8. So our solutions are x equals 2 or x equals negative 8. All right, almost there, guys. We're going to do 2 more slightly difficult problems. All right, so now we have an ugly problem here. We got 2 ugly problems and we're going to solve for it, right? So imagine I have 2x squared plus 9 equals 25. What I have to do right now is I have to, first of all, I got to isolate the thing with the x squared. So that whole block, 2x squared, has to be by itself, either on the left side or the right side. This time it's on the left side. So let's go for it. So to get it by itself, we have to get rid of that plus 9 that we have right here. So I'm literally going to take this 9 and move it to the other side of this equation. And now we're left with, on the next line, 2x squared equals 25 minus 9. Well, 25 minus 9 is pretty easy to calculate. Do that on your calculator, you're going to get 16, and you have 2x squared. Now, we've isolated 2x squared, so now we're going to have to get rid of the 2 that's in front of the quantity that has the squared on it. So let's divide both sides by 2. So now you're left with x squared is equal to 8. So now let's use the square root property again. So we get x is equal to plus or minus the square root of 8. Ooh. Punch that in your calculator. The square root of 8 doesn't come out nice. So all we leave it as a rooted problem. So we end up with x is equal to the square root of 8, or x is equal to the negative root of 8. When you get to grade 11, you'll do some more advanced stuff. You'll get all the way down to the end here, where you're getting the final answers of x is equal to the square root of 8, or x is equal to the negative square root of 8. And we're done. So for this next problem, we have to identify the part that has the x squared term. So this entire complex where we have 4 times the quantity x minus 3 squared has to be by itself in order for us to successfully solve this. So what we're going to do right away is we're going to take the plus 9 that is here. We're going to move it over to the other side here. So when we move it to the other side, we're going to get the following. We're left with our 4 x minus 3 squared is equal to 25 minus 9. Now, just like before, 25 minus 9 was 16. So now we have 4 x minus 3 squared. Okay? So now we need to get this portion of our problem separated from the 4. So what we're going to do now is we're going to divide the 4 out. So now we're left with, on the left side, we get x minus 3 squared is equal to 16 divided by 4 on your calculator. You punch it in, you get a number. So in this case, you're going to get 4. So now let's get rid of the square that's on the left side. And to do that, we get rid of the square with x minus 3 is equal to, now remember, I just dropped the brackets right away because I don't need it anymore because it's now moved to the other side. So now we have plus or minus the square root of 4. Now, plus or minus the square root of 4 is 2. So we got plus or minus 2. So x minus 3 is equal to 2. So to make your life easy, take this minus 3, and we're going to move it over to the other side in front of the plus or minus 2. So now you're going to get x equals 3 plus or minus 2. And you break this down into 2 solutions. So x is equal to, well, what's 3 plus 2? 5. Or x is equal to 3 minus 2 on the other side. So minus 2, 3 minus 2, x equals 1. And there are your solutions. So now I'm going to ask you to do these basic problems. These questions, we'll call them part A, and part B, I'll have a video for that as well.